All right, let's look at the homework 7.8, problem number 7. All right, so let's evaluate this improper double integral. All right. All right, so first thing I would do is I'm going to split this exponential expression here. So this is going to be split it as, oh, maybe I'm going to go up here. All right, so it's going to be e to the negative x first, here, e to the negative x squared, sorry. And then you have another e to the negative y squared. So you multiply by e to the negative y squared. All right. Then you can see that here, first integral is done with respect to x, so which is here, right? So everything else is going to be considered to be a constant, especially y, right? So y is a constant, so I'm going to have a y right here, right? So you can actually kick this integral outside because it's just going to be a number, right? And here, there's a e to the negative y squared is also considered to be a number. So you can kick it outside of the first inner integral, right? So we can rewrite this guy as, right? So you have an integral from 0 to infinity, right? So we kicked out the y, and then we kicked out e to the negative y squared, right? Then you have an inner integral from 0 to infinity. Right, what's left is there's going to be x left over, which is here. Right, then you have e to the negative x squared. Right, so we took care of everyone, right? We took care of x, and y is kicked out. E to the negative y squared is kicked out, and we took care of this. Right, so you have dx dy. Right. Then you can see that if you look at this expression right here, right, the inner integral, right, this has completely nothing to do with y. So there's no y involved, which means that this is going to be considered to be constant. So we can kick this whole inner integral outside, right? So it's just a number, right? So this is going to be integral from 0 to infinity x e to the negative x squared dx, right? And multiply by integral from 0 to infinity y times e to the negative y squared dy, right? Then notice that you know, these are dummy variables, so these are exactly the same integral, right? So what you can do is just I'm lazy, so instead of you know, evaluating both of them, I'm going to evaluate one of them, and then you just have to square it because the results are going to be exactly the same. So we have an integral from 0 to infinity. I'll do the one with x. X e to the negative x squared dx. Then we just have to square that. All right. And then we know that how to deal with the improper integral, because this is just a one variable, so we've done it before. So this is the troublemaker. So what you can do is here, we still have to square it at the end. All right. But we're going to use replace the troublemaker. So since it's an upper limit, I'm going to put b instead. Then you have x e to the negative x squared. All right, and oh, actually, let me change this a bit. All right, so I you know, back up a little bit. All right. So what I'm going to do is actually, I'm going to do a substitution before we do the replacing with b. All right, substitution I would use would be, we're going to let u be, let's see, we're going to do, let's do a negative x squared, right? then we can take the derivative of u with respect to x. I'm just doing a substitution. All right, so you have a negative 2x. Then take the reciprocal of both sides. So dx over du is equal to 1 over negative 2x, right? Then we're going to multiply through by du so that we have an expression for dx. So dx is du over negative 2x, right? So I'm going to put that in. So we have an integral. All right, so I'm going to leave x as it is. All right, then this is going to be e to the u. All right, dx is du over negative 2x. Right? So originally, this is going from 0 to infinity, but we have to convert it. So here, if x is 0, u is also 0, so it's a 0. But if x is infinity, negative infinity squared would be negative infinity, right? So we have it's going from 0 to negative infinity, right? And then you just have to square that at the end, right? Here we can clean up a bit. Right here you have x on top and x on the bottom. You can cancel those out. All right, and one thing we can do is we can use the negative sign to switch the upper limit and the lower limit, because it looks natural if you have a negative number on the bottom. All right, so I'm going to use that. So I'm going to use this negative sign, so scratch it. Then we can put the negative infinity on the bottom and the positive infinity on top. All right. Then you have a 1 over, so let's see, here's there's a still constant 1 over 2. All right, so 1/2 is just a constant, so we can just kick it outside here. All right, so what you get is going to be, so you have integral, it's a 1/2 is outside. All right, so here's the integral. So what I'm going to do is I'm going to replace the troublemaker, which is negative infinity, by, I should probably use a. Then we can take the limit as a goes to negative infinity, and 0 is 0. And then you have e to the u and du, and square that later, right? So I'm going to come up here so that we have more room. All right, so here, all right, so you have a 1/2. All right, antiderivative would be, so you have a limit as a approaches negative infinity. All right, antiderivative e to the u with respect to u would be e to the u. And we are going from a to 0. Then we have to square that. Okay, so I'm using square bracket already, so I'm going to actually just change the type of bracket. I'm going to put a curly bracket so that I don't get confused with the other square bracket. So you have to square that. All right, so this is going to be, all right, so you're going to have, so now you have a 1/2. We want to take the limit as a approaches negative infinity. All right, plug in 0 for u, so it's going to be e to the 0 is 1, minus plugging a, so we have e to the a. All right, and I can go back to a square bracket. All right, so we have that. All right, so as you take the limit, you can see that here, if a goes to negative infinity, e to the negative infinity is getting smaller to 0. So this guy actually approaches 0, right? So what's left is a 1, and then you have 1/2. So it's going to be 1/2 squared is going to be 1/4, right? So this is the value of the improper double integral. Right, so let's type it in. All right, so answer we got was 1/4. So 1/4. All right, let's check the answer. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.